So in electromagnetic relays, we had gone through attracted armature relays. So in this attracted armature relays, we already completed hinged armature type, plunger type, balanced beam type, moving coil type, polarized iron type, and reed type. So these are the types of relays which were classified as a sub-classification for attracted armature relays. So here hinged armature type relay, plunger type relay, balanced beam type relay, moving coil type relay, polarized moving iron type relay, and the reed relays. So these are the attracted armature types. So in the classification, next we will move on to induction relays. First classification, within the first classification, electromagnetic relays. Within that, attracted armature type relays is completed. And now we are moving on to induction relays. So these induction relays are again classified into number of types. Induction disk relay, induction cup relay, printed disk relay. So these are the induction disk relays, and this is printed disk relay, induction cup relay. So like that. So we will be having some classification, and after completion of the classification, we will discuss about the torque equation. So how that disk, which is located in the induction relay, is going to rotate. That is what we are going to discuss. So coming to the basic explanation for the induction disk relay, this induction disk relay will work on the same principle of induction motor. What is induction motor principle? Mutual induction. సింగిల్ ఫేజ్ ట్రాన్స్ఫార్మర్ అయినా కావచ్చు, లేదంటే ఇండక్షన్ మోటార్ అయినా కావచ్చు, వాట్ ఎవర్ యూ కన్సిడర్ that they will work on the principle of mutual induction. Due to the current drawn by a coil, it induces EMF in another coil. That is called as mutual induction principle. So here, this is the relay coil, which is mounted on a core, or you may classify that as a magnetic material, just like we are considering core for transformer. So here this U-shaped core is considered for the relay, in between which there will be a aluminum disc, so which is pivoted exactly at the center of its axis. So this is the disc which is pivoted exactly at the center. సో సెంటర్ అంటే ఏం చెప్పచ్చు అంటే దీని పివోట్ అంటే డిస్క్ నార్మల్ సిడి తీసుకున్నారనుకోండి, నార్మల్ సిడీకి మధ్యలో సెంటర్ ఉంటుంది కదా, దాని మధ్యలో ఏదైనా సపోర్ట్ ఇచ్చేసి రొటేట్ చేస్తే ఆ సిడి ఏ విధంగా అయితే రొటేట్ అవుతుందో, జస్ట్ లైక్ దట్ దిస్ డిస్క్ ఈస్ గోయింగ్ టు బి సస్పెండెడ్ in between this pivot. And here this U-shape magnetic core will develop flux corresponding to the magnitude of current which is drawn by the relay coil. Whatever may be the relay coil current is there, based on that there will be a magnetic flux. Is it audible to you all?
Yes, sir.
So based on the current drawn by this magnetic core material, there will be what say a flux set up at the ends. This flux will interact with the disc here. So from the top, a magnitude of flux will interact with the disc, and from the bottom, another magnitude of flux will interact with the disc, which are opposite in direction, due to which there will be an action which happens there, due to which there will be a torque developed on the disc. So here, this disc will be considered as a short circuit material, which is placed in a alternating magnetic field. A simple principle, electromagnetic induction principle, Faraday's laws of electromagnetic induction. Whenever there is a coil located in a magnetic field, and whenever there is a relative motion between the magnetic field and the coil, EMF will get induced in the coil. That is Faraday's laws of electromagnetic induction, first law. So based on the same principle, here initially the disk will be in a stationary position. Disk will be in a stationary position, and whenever this relay coil carries current, this current will set up a magnetic field and top and bottom, and that magnetic field is an alternating magnetic field. So initially the disk is at stationary position. Whenever magnetic field is set up by this core, relay core, what happens? An EMF will get induced in this disk, due to which a torque will set up on the disk, and due to the torque set up on the disk tends to rotate. So this is the side view, you can imagine. So in olden days, there are induction type energy meters you might have observed, or you might have observed in our measurements lab, electrical measurements lab, calibration of energy meter. There is an experiment called calibration of energy meter. In that experiment, you might have observed that one. Similar to the working principle of induction energy meter, induction disk energy meter. So this relay is going to work. So this disk will be having a movable contact where it is separated from a fixed contact. So whenever this relay coil gets some current, due to which magnetic flux set up by the core material, which induces EMF in this disk, and due to which torque develops, and disk tends to rotate. While rotating, the movable coil is brought near to the fixed point. So ఈ రిలే ఏం చేస్తుంది, యాక్చువల్గా ఇట్ ఈస్ గోయింగ్ టు సెండ్ సిగ్నల్ టు ది ట్రిప్పింగ్ సర్క్యూట్. వాట్ ఈస్ ది ట్రిప్పింగ్ సర్క్యూట్? బ్రేకర్ కాంటాక్ట్స్. బ్రేకర్ కాంటాక్ట్ ని ఓపెన్ చేయడానికి ఏదైతే ట్రిప్పింగ్ సర్క్యూట్ ఉందో ఆ ట్రిప్పింగ్ సర్క్యూట్ ని క్లోజ్ చేస్తుంది. సో ప్రీవియస్లీ ద టూ contacts of the tripping circuit will be in open position whenever this relay is moving or rotating. While rotating, it is going to bring that moving contact near to the fixed contact, and finally at a position thus two contacts will get in touch. So whenever the two contacts get in touch, the tripping coil will get energized, due to which the tripping coil will open the breaker contacts. This is what it is going to happen there. Now here, this is a braking magnet. So what is the need of a braking magnet? In generally, whenever there is a flux set up by this core, flux induces some EMF and torque develops, due to which the rotor, you may imagine this disc as the rotor of an induction motor, and this as the stator of an induction motor. The C-typed core as the stator of induction motor. So whenever stator is energized, it will develop magnetic flux, due to which the rotor tends to rotate. Since it is free from rotation, free from any opposition, it will be freely moving in the space there, disc energy. Since it is free from rotation, what happens there? Even though in the absence of magnetic field, the disk continues to rotate. So initially, let us imagine the current drawn by this relay coil is 0 at time t equal to 0. Now, after certain time period, the relay coil carries some magnitude of current, due to which this core will get magnetized and it will induce EMF in the disk. Due to the torque developed in the disk tends to rotate. Let us suppose after that time, if current again becomes equal to 0, then what about the magnetic field set up by the core? That will become 0. So even though the magnetic field set up by the core becomes 0, the disk continues to rotate. That is called as creeping effect. In the absence of magnetic field also, if the disk tends to rotate, that effect is called as creeping effect, and that error or creeping error, you may classify that. So in order to overcome that creeping error, there is a braking magnet which is located or mounted on the periphery of the disk. What happens here? This braking magnet will set up an appropriate torque such that the disk stops at an instant of de-energization of this relay coil. So whenever this relay coil is de-energized, that is when the current drawn by the relay coil is zero or not up to the level of developing torque in the disk, then due to the braking magnet, the disk becomes stationary. That means it will remain in a stationary position. That is the reason for considering this braking magnet. Is it clear? అర్థం అవుతుంది అందరికి?
Yes, sir.
Okay, fine. So I am listening one or two answers. That's it. So this is what we will consider here. For a that means for simple construction type, you may classify this one. And this is for shaded pole induction disk relay. What is the purpose of providing shaded poles? Shaded rings అనేది ఎందుకు provide చేస్తాం induction motor లో actual గా? In order to provide a phase shift in between what say one phase and another phase. So here we are having only one phase. The upper portion of the pole and the lower portion of the pole in this simple construction will develop the same magnitude of the magnetic field in opposite direction with equal phase, the same phase. So thereby the disk will not rotate appropriately. That is the reason for which we will go for the next construction, shaded pole. So what these shaded rings are going to do here is they are going to provide a phase shift between the upper portion flux and the lower portion flux. So whenever there is a phase shift in between upper portion and lower portion flux, automatically due to the phase shift, the net torque developed on the disk will much easily rotate the disk there. That is the reason for which we will be using the shaded rings in the induction disk relay. So there is another construction. Whatever may be the construction that we are going to discuss further. So this is the basic one. The first one is the basic one. Whenever the relay coil carries current, you may assume this has a pole, electromagnetic pole. Since it is in C or U shape, whatever you consider, the upper portion will develop magnetic field and the lower portion also will develop magnetic field. The resultant of two magnetic fields will set up a torque on the disk. So in order to provide phase shifts in between the upper portion flux and lower portion flux, we will be considering this shaded rings. There is another construction for this, which is wattmetric type induction disk relay. Wattmetric type induction disk relay. Here, the same coil will develop two fluxes which are interacting with the disk. But here, in order to provide a better phase shift, we will be considering two poles. One is upper pole and one is bottom pole. So this bottom pole is energized by the flux developed by the upper pole. So this entire arrangement, you may consider this entire arrangement as upper pole and this one as lower pole. This lower pole is short circuited. The coil which is wounded on the lower pole is short circuited and it is energized by the magnetic field which is set up by the upper pole. So this upper pole is energized by the relay coil. So there is a plug setting. I will discuss about this plug setting later. Based on the current measuring capability or the operating current requirement, we will set the plug. Plug setting అనేది మనకు ఏ కరెంట్ దగ్గర ఆపరేట్ అవ్వాలి రిలే అనేది బేస్ చేసుకొని క్లాసిఫై చేసుకోవడానికి ఆ ప్లగ్ సెట్టింగ్ యూజ్ చేస్తాం. Just we will change the setting, that's it. Okay, forget about that. I will explain that later. So there is a scope for discussing that later. Okay, fine. So here, this is the relay coil. So whenever current is drawn by the relay coil, for the first time instant, the upper pole will get energized. Why? Since the relay coil is directly wounded on the upper pole. Upper pole will get energized at the very first instant. Whenever this upper pole gets energized, due to the flux set up by the upper pole, there will be an EMF induced in the coil which is wounded on the lower pole, due to which the lower pole also develops some flux which will be in opposite direction to the upper pole. According to Lenz's law, whatever may be the cause which is used to develop the induced EMF in a coil, that induced EMF will oppose the very cause which is used to develop. అంటే ఇక్కడ ఈ పోల్ వల్ల అప్పర్ పోల్ వల్ల లోయర్ పోల్ లో ఈఎంఎఫ్ ఇండ్యూస్ అయింది కాబట్టి లోయర్ పోల్ యొక్క ఈఎంఎఫ్ అనేది అప్పర్ పోల్ ఈఎంఎఫ్ కి ఆపోజిట్ డైరెక్షన్ లో ఉంటుంది. Since these two are in opposite direction, induced EMFs are in opposite direction, automatically the fluxes which are set up by the upper pole and lower pole will be always in opposite direction. And the part of lower pole coil is mounted on the upper pole, due to which there will be a phase shift provided in between the upper pole flux and lower pole flux. So this is the disk here. So whenever the two fluxes interacts with the disk, automatically there will be a torque developed on the disk, due to which the disk tends to rotate. While rotating, see here, these two are the trip coil contacts. While rotation, this disk will close the trip coil contacts, due to which the trip coil will get energized and finally it is going to operate the breaker. So this is the braking magnet. What is the need of a braking magnet? To overcome the creeping error, we are using this braking magnet. That is the need of a braking magnet. So this is the very simple explanation for induction relays. And coming to the next classification of induction relay, printed disk type relay. Printed disk type relay. Just like PCB, printed circuit board, the circuit is printed on this disk. All these arrangements are made in order to provide a phase shift between two fluxes, which results in the net torque developed on the disk. సో ఆ డిస్క్ పైన డెవలప్ అయ్యే టార్క్ ఏదైతే ఉందో ఆ టార్క్ ని డెవలప్ చేయడానికి ఏ టూ ఫ్లక్సెస్ అయితే రెస్పాన్సిబుల్ అవుతాయో ఆ టూ ఫ్లక్సెస్ కి మధ్యలో ఫేస్ షిఫ్ట్ ప్రొవైడ్ చేయడానికి ఈ అరేంజ్మెంట్స్ అన్ని చేస్తారు. వాట్ ఆర్ ది అరేంజ్మెంట్స్ మేడ్? జస్ట్ కమింగ్ టు దిస్ వన్ ఫస్ట్, షేడెడ్ రింగ్స్, వాట్మెట్రిక్ టైప్. వాట్మెట్రిక్ అంటే జస్ట్ లైక్ ఎనర్జీ మీటర్, వాట్మెట్రిక్ టైప్. నెక్స్ట్ printed disk, and here a simple induction couple relay. Induction couple relay we will discuss. Fine. So there will be a printed disk which is located in between the poles whenever the coil gets energized here. So this coil itself will become the magnet. So here this is a permanent magnet, and the relay coil is located on the disk itself. You can see the difference in between this one and this one. Here a relay coil is mounted on the pole, whereas here there will be a permanent magnet where the relay coil is relay coil current is directly fed to the circuit which is printed on the disk. So this is a permanent magnet and there is a current. Whenever a current carrying conductor is placed in a magnetic field, what happens? Force acts on the conductor, motor principle. Force acts on the conductor, due to which the conductor tends to rotate. Since the conductor is mounted on the disk here, whenever this is energized by the relay current, this printed circuit disk will set up flux which is going to interact with the permanent magnet flux, and there will be a torque developed on the disk. due to which the disk tends to rotate. Since it is pivoted on a spindle at its axis, it is going to rotate based on the phase shift. So while rotating, it is going to short the trip coil circuit, due to which the circuit breaker is going to operate. And after operation, what should be done there? This contact, which is closed, trip coil contact, which is closed, must get open again. So that is why we will be considering a spring at the bottom of the spindle, which provides a restoring torque, operating torque and restoring torque. You might have learned in measurements. Meters లో మీటర్ పాయింటర్ అనేది డిఫ్లెక్ట్ అవుతుంది, డిఫ్లెక్టింగ్ టార్క్ అంటాం. So that deflecting torque is responsible for the spindle to deflect or for the pointer to deflect. And after taking the measurement, if you switch off the circuit, what should happen there? That pointer will come back to the zero position again. What is the parameter which brings the pointer back to its original position? That is restoring torque. That restoring torque is provided by a spring which is solidly fixed at the bottom here. So like that. So suppose let us say whenever current carries here, the disk rotates in a clockwise direction. While rotating in a clockwise direction, it is going to short the trip coil circuit. And after that, the breaker opens the contact. Breaker contact open avangane emautundi fault nunchi trip చేసినట్లు circuit ni. So after tripping there, the current drawn by the relay coil becomes zero. Current drawn by the relay coil zero అయిపోయింది అనుకోండి, అప్పుడు ఏమవ్వాలి? ఈ కాంటాక్ట్ మళ్ళీ రావాలి. అంటే అప్పుడు ఏమవుతుంది? This disk will rotate in anti-clockwise direction due to the tensile force which is developed by the spring suspended at the bottom of the spindle. This disk will rotate in anti-clockwise direction, due to which these two contacts will open again after fault. ఒకవేళ అలా జరగకపోతే ఏమవుతుంది? ఫాల్ట్ అక్కర్ అవుతుంది, రొటేట్ ఒక స్ప్రింగ్స్ పెట్టలేదు అనుకోండి, ఫాల్ట్ అక్కర్ అవుతుంది, డిస్క్ రొటేట్ అవుతుంది, ఈ టూ కాంటాక్ట్స్ ని క్లోజ్ చేస్తుంది. క్లోజ్ చేయగానే బ్రేకర్ ఆపరేట్ అవుతుంది, బ్రేకర్ బ్రేక్ చేసేస్తుంది సర్క్యూట్ ని. మళ్ళీ ఫాల్ట్ ని రెక్టిఫై చేసిన తర్వాత మళ్ళీ లైన్ ని లైవ్ లోకి తీసుకొచ్చారంటే ఏమవుతుంది? ఆల్రెడీ దిస్ కాంటాక్ట్ ఈస్ క్లోజ్డ్, మళ్ళీ ట్రిప్ అయిపోతుంది. సో అలా జరగకుండా ఉండాలి అంటే ఆఫ్టర్ ఫాల్ట్ ద డిస్క్ మస్ట్ రొటేట్ ఇన్ యాంటీ క్లాక్వైజ్ డైరెక్షన్, by which this moving contact will move away from the trip coil circuit contacts, and the trip coil circuit contacts will become open again, by which the trip coil will get de-energized. It will not attract the breaker contacts. That's it. So this is about printed disk relay. Do observe the difference in between the normal induction relay and printed disk relay. So for a normal induction relay, the relay coil is directly mounted on the pole. This pole is an electromagnetic pole. Whereas for a printed disk relay, there will be a permanent magnet, and the relay coil will be direct. I mean, whatever may the current drawn by the relay coil will be directly given to the disk here. That means the relay coil is mounted on the disk or printed on the disk. That is why it is called as a printed disk relay. So I will tell the ranges of fault currents at which these relays may be operated. Actually, the VA, volt ampere burden పైన బేస్ చేసుకొని ఉంటుంది అనమాట. So generally, this induction disk relays or induction relays will be operating with for a faulty condition with a volt ampere burden of 2.5 VA. 2.5 volt ampere burden దగ్గర ఆపరేట్ చేస్తుంది. And it operates within 2 duty cycles. 2 duty cycles అంటే ఏమి? One full waveform and another full waveform. Sine wave అంటే ఏమి? Half wave. one positive wave and one negative wave. So అలాగా two positive waves, two negative waves వచ్చే లోపల this disk relay will operate there. The overrun can be usually 20 times the current setting. సో ఏదైతే కరెంట్ సెట్టింగ్ మనం పెడతామో ఇంటరప్షన్ కి ఆ కరెంట్ సెట్టింగ్ కన్నా 20 times ఎక్కువ కరెంట్ ఉన్నా కూడా ఇట్ విల్ withstand that. So this induction disk relay. So this is the general operation of induction disk relay. Now we will go for induction cup relay. See here at the bottom, at the axis of this pole. So these four squares will constitute a single material on which the windings are wounded. Relay coil windings are wounded with a phase difference. ఒక ఫేజ్ డిఫరెన్స్ తోటి ఈ రిలే కాయిల్ వైండింగ్స్ అనేటివి వౌండ్ చేస్తారు ఇక్కడ. సో at the center of which there will be a stationary core, just like cup. నార్మల్ గా టీ కప్ అంటాం కదా, ఆ టీ కప్ లాంటిది ఒకటి ఉంటుంది మధ్యలో. దట్ విల్ బి యాక్టింగ్ యాజ్ ఎ కోర్ టు విచ్ a moving contact is suspended. Just like a cup handle అనుకోండి, ఆ కప్ హ్యాండిల్ ని ఈ మూవింగ్ కాంటాక్ట్ గా అస్యూమ్ చేసుకోవచ్చు. So whenever this relay coil will get energized, then due to the torque developed on the cup, this cup tends to rotate. See here, this is a moving contact and this is a fixed contact. These two contacts will be connected to the trip circuit. So while it is moving, let us imagine that this cup is rotating in clockwise direction. While it is rotating in clockwise direction, this moving contact will come in touch with the fixed contact, due to which the trip coil circuit gets energized. At the bottom or at the axis of this cup, there will be a spring connected, and after fault, the cup will rotate in anti-clockwise direction. So this is what it is going to happen in induction relays. Is it clear, everyone?
Yes, sir.
Yes, sir.
So this is about induction relays. Now we will move on to the torque equation, the equation of torque, which is set up by the two fluxes. See here, in this diagram, flux phi2 develops force F2, flux phi1 develops force F1. So this F1 will be depending on I2. Why? Since this flux comes into the periphery of eddy current, which is set up by phi2. Okay, so let me explain here with the clarity. So whenever flux phi2 is interacting with the disk, this is the disk. Whenever flux phi2 is interacting with the disk, this develops an EMF induced in the disk, due to which an eddy current will set to flow. Since we are using an aluminum disk, the self-inductance is negligible. The self-inductance is very much negligible. So this I2 is nothing but eddy current which is set up on the disk due to the induced EMF for phi2. Okay, and this flux phi1, whenever it is interacting with the disk, it sets up an eddy current I1 due to induced EMF E1. Let us imagine E1 as the induced EMF due to phi1 and E2 as the induced EMF due to phi2. So that E2 will set up I2, which is an eddy current on the disk, and E1 will set up I1, which is an eddy current on the disk due to phi1. and this eddy current or this flux will interact with the eddy current caused by phi 2. Phi 1 will get interact with eddy current phi I2, which is caused due to phi 2. Thereby, a force F1 is set up. F1 will set up due to flux interaction of flux of phi 1 with I2, and F2 will set up due to the interaction of flux phi 2 with I1. I1 is the eddy current here, which is set up by phi 1. Are you getting my point? Opposite గా తీసుకుంటున్నాం ఇక్కడ. Whenever flux phi 2 interacts with I1, F2 amount of force is developed. Whenever flux phi 1 is interacting with I2, a net amount of force F1 is set up. Since these two fluxes are having a phase difference, or they are in opposite direction, let us imagine these two are represented in opposite direction, F1 and F2. Let me write the equations for them. Generally, phi 1 అంటే ఏం రాస్తాం? Instantaneous amount of flux. That instantaneous amount of flux will be given phi 1 equal to phi 1 m sin omega t. So where phi 1 is the instantaneous amount of flux, phi 1 m is the maximum value of flux, phi 1, and sin omega t is nothing but with respect to the phase shift. Since it is a sinusoidal component, we are considering here sin omega t. And similarly, phi 2 is written as phi 2m sin omega t plus theta. Why we have to consider sin omega t plus theta? Sin omega t plus theta. Why? Since there is a phase shift in between phi 1 and phi 2, that phase shift is represented as theta here. నార్మల్గా సైన్ ఒమేగా టీ అని రాసేసాం అనుకోండి, ఫేజ్ షిఫ్ట్ ఏముండదు. ఈక్వల్ అండ్ ఆపోజిట్ ఉంటే నెట్ ఫోర్స్ ఏమవుతుంది? దట్ విల్ బికమ్ జీరో. దట్ ఈస్ ది సేమ్ ప్రాబ్లమ్ విచ్ వీ కన్సిడర్డ్ ఫర్ సింగిల్ ఫేజ్ ఇండక్షన్ మోటార్. సింగిల్ ఫేజ్ ఇండక్షన్ మోటార్ ఈస్ నాట్ సెల్ఫ్ స్టార్టింగ్ అంటాం. ఎందుకు సింగిల్ ఫేజ్ ఇండక్షన్ మోటార్ సెల్ఫ్ స్టార్టింగ్ కాదు? నార్మల్గా at the time of starting there will be a forward torque developed due to the positive half cycle and backward torque developed due to negative half cycle. Both forward torque and backward torque are equal in magnitude but opposite in direction, due to which the resultant torque becomes zero. Net torque తీసుకుంటే ఏమవుతుంది? డిఫరెన్స్ బిట్వీన్ ద టూ టార్క్స్ అవుతుంది, కాబట్టి నెట్ టార్క్ అనేది జీరో అవుతుంది. నెట్ టార్క్ జీరో ఉంటుంది కాబట్టి సింగిల్ ఫేజ్ ఇండక్షన్ మోటార్ సెల్ఫ్ స్టార్టింగ్ కాదు అంటాం. అదే విధంగా ఇక్కడ కన్సిడర్ చేయాల్సి వస్తుంది. ఇఫ్ దేర్ ఈస్ నో ఫేజ్ షిఫ్ట్ ప్రొవైడెడ్ ఇన్ బిట్వీన్ ది టూ ఫ్లక్సెస్ phi 1 and phi 2, then even at the presence of fault also this disc will not rotate, due to which the fault will not get cleared. So that is the purpose for which we have to consider a phase shift in between two fluxes. Is it clear? Okay, so these fluxes will induce EMFs in the disk. Let E1 be the induced EMF due to flux phi 1. E1 is proportional to d phi 1 by dt. According to Faraday's laws of electromagnetic induction, second law, the amount of EMF induced in a coil is directly proportional to rate of change of flux. So according to that, I had written this equation, and substituting phi 1 in this, you can write this as proportional to phi m1 cos omega t. D by dt of sin omega t cos omega t. So correspondingly, you will get E2 as EMF induced due to flux phi 2 d phi 2 by dt. So which can be written as phi 2m phi 2m cos omega t plus theta. Is it clear? So phi 1 is the amount of flux set up by the upper magnet or upper pole, and phi 2 is the amount of flux set up by the bottom magnet or bottom pole. So since they are having a phase shift is provided here, theta. Theta is the phase shift in between phi 1 and phi 2. So phi 1 induces EMF E1 in the disk, which is d phi 1 by dt. So thereby you will get E1 proportional to phi m1 phi 1m. Sorry for phi 1m. So maximum value of flux corresponding to phi 1 into omega t. And similarly, phi 2 will induce E2 in the disk, which is proportional to d phi 2 by dt, and it is proportional to this value. And here, E1 sets an eddy current I1 in the disk. E1 sets an eddy current I1 in the disk, which is proportional to E1, the magnitude of E1. Why? Based on the magnitude of E1 itself, the magnitude of eddy current will depend. So that's why I1 is proportional to E1, and finally you may classify that as proportional to phi 1m cos omega t. So finally what you can tell, I1 is proportional to phi 1m cos omega t. And similarly here E2 will set an eddy current I2 in the disk, which is proportional to E2. So finally you can write I2 is proportional to phi 2m cos omega t plus theta. And you can say I2 is proportional to phi 2m cos omega t plus theta. And this I1 will set up a force. What is that force? F1. I1 will set up a force F1, which is proportional to phi 1 I2. So here you can see in the diagram, F1 is set up due to the interaction of phi 1 with I2. So that's why I am writing the expression as phi 1 I2. So F1 is proportional to phi 1 I2. So which is proportional to, what is phi 1? Phi 1m sin omega t. What is I2? Phi 1m cos omega t. So not I1, phi 2, I2. Phi 2m cos omega t plus theta. Let it be like that. Okay, see here. Phi 1, I am substituting phi 1 here. What is phi 1? Phi 1m sin omega t into I2. What is I2? Phi 2m cos omega t plus theta. Phi 2m cos omega t plus theta. So which is proportional to phi 1m phi 2m sin omega t into cos omega t plus theta. So what is this? This is the amount of flux F1. Similarly, force F2. Force F2 is proportional to phi to I1. So F2 is developed due to the interaction of flux of phi 2 with I1, as if we had seen in the diagram. So here phi 2, what is phi 2? Phi 2m sine omega t plus theta, I1 phi 1m cos omega t. So finally you can write phi 1m phi 2m sine omega t plus theta cos omega t. What is it? F2. Now the net amount of force which is set up will be given by F equal to F2 minus F1. So if you substitute that, phi 1 m, phi 2 m are the common parameters. Phi 1 m you may consider the proportionality itself here. Phi 1 m, phi 2 m as the common parameters. So if you take that as common, sine omega t plus theta cos omega t minus sine omega t cos omega t plus theta. So which is in the form of sin A cos B minus cos A sin B. Sin A minus B. Sin A minus B వేస్తే ఏమొస్తుంది? Phi 1m, phi 2m sin theta. Omega t gets cancelled. You will get only sin theta. So the net amount of force which is developed will be proportional to phi 1, phi 2 sin theta, where phi 1 and phi 2 are the RMS values of the fluxes set up by the upper and bottom magnets. So ఇక్కడ వచ్చేసరికి ఏమైతుంది, maximum values ఇక్కడికి వచ్చేసరికి RMS values. Just simply removing that maximum and representing that phi 1 and phi 2 here. So if you remove this proportionality and write phi 1 in terms of I, phi in terms of I, k into I1, I2 sin theta. Enduku? So this is also proportional to I1, I2 sin theta. Why? Phi 1 is proportional to I1 and phi 2 is proportional to I2 here, where I1 and I2 are nothing but the eddy currents which are set up there due to phi 1 and phi 2. If same magnetic flux is developing the two currents, then instead of taking I1 and I2, you may simply consider I. Same magnetic flux అనేది two currents ని develop చేస్తుంది అంటే I into I, you will get I square sin theta. So these are the expressions for force which is set up by the disk, which is set up on the disk. In general, F is written as K into M N sin theta, where Mn are nothing but actuating currents produced by phi 1 and phi 2. M is the actuating current produced by phi 1 and N is the actuating current produced by phi 2. This is about the expression for force or torque. Is it clear?
Yes, sir. Clear, sir.
Yes,
Note
sir.
చేసుకున్నారా అందరూ?
Yes, sir. Note చేసుకున్నాం, sir.
Yes, sir. Notice.
Okay, fine. So time is completed. We will wind up the session now, and we'll move on to the next concept in the next class. Any doubts up to now? Please be on the class. I won't be responsible if you people leave the class before registering the attendance.